it for today. I can write, identify, and graph parallel and perpendicular linear equations. I can write, identify, and graph parallel and perpendicular linear equations. Let's read together. 1, 2, 3. I can write, identify, and graph parallel and perpendicular linear equations. So we don't need a fair model because we already know what linear equations are, right? We've done this before, but we do need steps. Copy these 5 steps only. Only 5 steps for today. And some of them we already saw before. Look at steps 3, 4, and 5. When we graph, don't we use the y-intercept, the slope, and then we graph our lines? Yes. But the first 2 steps, we already know how to do the first one. We're going to slip in here the second step, which is comparing slopes and intercepts to identify if the lines are parallel or perpendicular. Copy that, please. All right, so the 2 steps. The first one, solve for y and write the equation slope-intercept form. Do we know how to do that? Yes. Step 2, basically, we're just going to compare slopes and intercepts to identify the lines, if the lines are parallel or perpendicular. So, how does that go? Here we go. So just pay attention really quick, pens down and eyes up here. So for parallel lines, according to the definition that they give us, look up please, it says lines that are in the same plane and have no points in common. They will never intersect. How do they look? They look like this. This blue one, this red one, and here are their equations. Now let me show you the perpendicular ones. Perpendicular definition says are lines that are intersect to form a right angle or right angles. This is the graph for those. And if you notice, the red and the blue are intersecting. They make a 90-degree angle, and these are their equations. Yes? So now we need to change this definition to make it more, I guess, in our own words. So here we go. So the first thing that we're going to keep from the definition, parallel lines will never intersect. That's what I would write to get started, comma. Hold on before you write anything else. I still want us to see what else makes them parallel. Look up, please. Look up, please. Tell your neighbor what that makes them. Okay, so what was that, Andrea? What did your neighbor say? Same slope. Hands if you agree with that. That is correct. So far so good? Yes. And what would be the last part? Think about it first. Here, look what I'm circling. This one and this one. Tell your neighbor what would be the last part of the definition. It could be negative, because if I was to move this down here, but what does that tell us about the last part? What is it? Go ahead. It says no points in common, but what does that mean in regards to this part of the equation? Very good. The y-intercept is different. Does that make sense? Do they have different y-intercepts? Yes. Do they have the same slope? Yes. So write this down, please. I want you to write parallel lines will never intersect. No, underneath the steps. Have the same slope and what else? What would be our full definition? Parallel lines will never intersect, have the same slope, and what else? And y-intercepts are different, or different y-intercepts. Very good. Copy that. Okay. Now let me show you perpendiculars. According to the definition, there are 2 lines that when they intersect, they make right angles. Here's one, here's the other. If this one's 90 degrees, that means this one's 90 degrees. If this one's 90 degrees, that means that the rest of them are 90 degrees. Okay. But look at this. See if everybody sees what I see. Look up. So tell your neighbor what would be part of the definition. Slopes are reciprocal, but look at this last word, inverses. Here we look up, so watch. What is the reciprocal of 2/3? 3/2. But what is the inverse of a negative? Positive. So look at the signs. One of them is one and the other one is the other. So they need to be the reciprocal inverses.
There's a difference between reciprocal and reciprocal inverses.
Yes. Reciprocal, look up please. If I was to give you -2, we know that the reciprocal is -1/2. Do they have the same sign? Yes, and it's the reciprocal. However, reciprocal inverse, we do the same thing to the number. 2/3 becomes 3/2, but the sign is inverse. Okay? However, look at this part. Here, if I showed you the y-intercepts, they're different. But what if I did this? What if I took this line and I moved it this way? Hold on. Alright, and I was to erase it from here. Is that still 90 degrees? Yes. Are they still perpendicular? Yes. So we know that they have the reciprocal inverse slopes. But in this case, don't they have the same intercept? Did they have the same intercept when it was over here? No. So what would you conclude in regards to intercepts? For parallels, they have to have the same slope, different intercepts. And for perpendicular, the intercepts. What else? How can we write it in our definition? Intercepts could or could not be the same? Yeah, okay. Could or could not be the same. In other words, like Isaac said, it don't matter. Okay. Oh, so this is what I want you to write for the definition. Perpendicular lines form right angles, have slopes that are reciprocal inverses, and the intercepts could or could not be the same. So they don't. It doesn't really matter whether you write the same intercept or not. Everybody got it? Okay, let's move on. Example 1. Okay, I'll give you a little bit of time, 10 seconds. Copy this one, example 1. Example 1, it says, identify which lines are parallel. Example 1, copy that, identify which lines are parallel. Let me give you the different equations that they give us here, because from far away maybe it doesn't look like different ones, but they are. Here's one. Here's another. Here's another. And here's another. You don't need graph paper. We're going to identify parallel lines without graphing right now. Copy that, please. Okay, here we go. Can you read us step 1 from the notes, please, David? So let's look at all these 4. Step 1 says solve for y and write the equation slope-intercept form. Are all these equations solved for y, number 1, and written in slope-intercept form? Yes. Yeah, solve for y, slope-intercept form, solve for y, slope-intercept form. Same here and same here. Step 2. Read step 2, please.
Compare the slope and intercept and identify if the lines are parallel or perpendicular.
So we're going to look at the slopes first. So look at this slope. This is 5/3. According to what we learn in definition, parallel lines have the same slope. Is there another line that has 5/3 for the slope? Yes. So it's this one. So what other thing needs to be true for both to be parallel? Yes? The y-intercept needs to be different. This is -2 and this is +4. Therefore, those two are parallel lines. Everybody understand that? So this is how I want you to write this. Once you identify, you write y equals 5/3 x minus 2, and look at this symbol, is parallel to y equals 5/3 x plus 4. And you can find the symbol in the word parallel, right? Yeah. Let's find out right now. So this one, this set of lines are parallel. Let's look at the other ones. We got y equals x, and the other one is y equals x plus 1. Is this one in slope-intercept form? Yes. What is the slope? 1 over 1. What is the slope here? 1 over 1. What is my y-intercept for this one? 0, so it's plus 0. And what is this one? 1. So are these two parallel? Yes, so therefore we write parallel. So was this one written in slope-intercept form? Yes. Okay. Fairly simple? And that's it? Yeah, it is. It is one of the, probably the simplest lessons. Let's go to the next one. But this one, notice that all of these were solved for y. Copy this next example, please. Example number 2. No. Example number 2 says, identify which lines are parallel. Write these down. Y equals 2x minus 3. Y equals -2/3 x plus 3. 2x plus 3y equals 8, and y plus 1 equals 3 times x minus 3. Copy those, please, and then we'll go over it together. Okay, let's see. Is the first one in slope-intercept form? Is the second one? Is the third one? No, that means we need to start working on that one. That means I'm not going to zoom in so you guys can finish copying those. You're still copying. But let's solve for y. What do I need to do here? Need to move the x to the other side, so we subtract 2x, subtract 2x. You're doing this one together. These cancel. We're left with 3y equals -2x plus 8. What's my next step? Divide by 3, divide by 3. Y equals -2/3 x plus 8 divided by 3 is 2.6 repeating. There it is. Is that in slope-intercept form? Yes, so we're done with this one. Let's go over to the last one. To solve for y, we need to subtract 1 to each side. But what did I say if it had a parenthesis? You distribute first. So this is 3x minus 9 equals y plus 1. Now we subtract 1 to each side. Y equals 3x minus 10. Now looking at those 4 equations, which ones have the same slope? Yeah. The second and the third, do they have the same slope? Yes. Do they have different intercept? Yes, they do. Therefore, they are parallel. Y equals -2/3 x plus 3 is parallel to y equals -2/3 x plus 2.6. And we're done. Are the other two parallel? No, because the slopes are totally different. Yeah.
Do you want us to write the one with slope-intercept form as an answer?
This one?
Yeah.
Yeah, this is what I want for an answer. Okay, let's go to the next one. Look at these. It says, identify which lines are parallel. So, without you copying it, look at them. Tell your neighbor which are parallel. So I don't even have to graph these, but by looking at them, these have the same slope, different intercepts, so the first two are parallel, yes? But look, let me graph these two to see how these look. This is y negative 4, which is right here. My line goes through there. What kind of line is that? It's a horizontal line, okay? And look at this one, x equals 1. X equals 1 is right here. And my line's going to go through there. Oh, sorry. Are those lines parallel? What are those lines? Perpendicular. Why? Because they form what? 90-degree angles. Are you with me? All right. So, last one. Copy this one, please. Send a gopher to get graph paper if you don't have any. Okay. So, they give you 4 points. -1, 3, 3, 3, 2, -1, and -2, -1. And they're asking this. Pay attention, please. They're asking, show that JKLM is a parallelogram. So, let me refresh your memory. Look up, please. In order for this to be a parallelogram, that means this side has to be parallel to this side, and this side has to be parallel to this side. That's what that was. That's a parallel. Well, squares are also parallelograms if you have the opposite sides parallel to one another. So check this out. So what I'm going to check, look up please, I'm going to check to see if, first I'm going to check this one. I'm going to check to see if MJ, get it, MJ is parallel to LK. How can we check that? To see, we can check it using the slope. So what would be our slope from here to here? Let's see, 1, 2, 3, 4. How many to the right? 1. So my slope is 4/1. So let's see if the slope is the same for this one. 1, 2, 3, 4. How many to the right? 1. So my slope is 4/1. Therefore, these are parallel. Are we there so far? So now I need to check these two. ML to see if it's parallel to JK. What kind of slope is ML? And JK? So if both of them are 0, are these parallel? Yes. So what can we conclude? That JKLM is a parallelogram. So your home plate for tonight, there's a play sheet. There's a play sheet I printed for you guys over here. So make sure you work on that. Put all my materials down, please. Make sure you bring me your sign Saturday Academy and sign progress tomorrow. Have a good one, everyone. See you guys tomorrow.